Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now the chapter is coordination compound, that is for class 12 and according to CBSE syllabus. Here part 7D, that means here the part 7D, that is optical isomerism. Optical isomerism, that is a part of stereoisomerism. Stereoisomerisms are two types. One is geometrical isomerism and next one is optical isomerism. I have explained in 7C in two parts what is meant by geometrical isomerism and what are the examples of geometrical isomerism. And here also I have explained if coordination number is 4 and if the coordination number is 6, what are the structures for the coordination compounds. Now you can observe this is optical isomerism. Optical isomerism means optical isomers are produced. They are exhibited by the chiral molecules. Optical isomers exhibited by the chiral molecule. What is meant by chiral molecule? There is no plane of symmetry. If you divide in the middle and both sides are not equal, then it is called not plane of symmetry. That means you can sure that optical isomerism only takes place where the molecule is chiral, that is no plane of symmetry. Now optical isomers, that is why they are mirror of each other. They only form mirror, just like our palm. You can find it is not a plane. There is no plane of symmetry, and there is a chiral molecule or chiral part and no plane of symmetry. If you divide here, you can observe this side is thumb, this side the other fingers. So here they form mirror image. If you see this, it can form mirror image like this, and now they are not superimposed. That means you can't place this one, they are not superimposed. That is why they form mirror image. This actually optical isomerism, isomers, the parts are in the organic chemistry, it is better. Now they are called enantiomers. That means the optical isomers, they are not superimposed each other and they can form mirror image, and that is called enantiomers. That means what is enantiomers? They are optical isomers. They are not imposed by each other and they are mirror image. And there is no plane of symmetry. If this case happening, that is called optical active. What is mean optical active? Optical isomers are optical active because they are not superimposed each other. And here it rotates the plane of polarized light. What is plane of polarized light? You will learn in organic chemistry. Now only remember rotate the plane of polarized light. Equally but in opposite direction. Opposite direction, one direction left, right. One direction right side, one direction left side. They mean they will rotate equally angle but in opposite direction. That is one side minus, one side called plus. Then what is that one? Towards left side. This is suppose this is left side. If towards left side, that is called minus levorotatory. If towards right is called dextrorotatory. That means here you can see this is the right part and this is the left part. They are equal in opposite direction and they are called dextrorotatory. If right side, dextrorotatory. If left side, levorotatory. Then it is called L and R, levorotatory and dextrorotatory. Sorry, not left, right, that is called dextrorotatory. So D and it is L. I can say right side and you can say left side. That means if you rotate right side, that is called dextrorotatory. If you rotate left side, it is called levorotatory. Complex with coordination number 4 and 6, they shows optical isomers. Coordination number 4 and 6, they shows optical isomers. Generally common in octahedral complex, that means coordination 6. If coordination 6 and didental ligand is present, surely it will show optical isomers. But in coordination number 4, there are two types of complex. One is square planar, another is a tetrahedral. So square planar complex never shows this type of optical isomerism and never form optical isomers, because there is a plane of symmetry. If you caught in the middle, this side you can this side find the same. That is why there is a plane of symmetry. That is why the square planar complex never shows that is your optical isomerism. Now again I want to explain in shortcut. Then optical isomers, they form mirror image and they are not superimposed by each other, and they are chiral. They are exhibited, these optical isomers shown by the chiral molecule. What is chiral molecule? They are called plane of symmetry, and these optical isomers also called enantiomers, and they optical isomers rotate the plane for polarized light to the right side and left side. If right side, that is called dextrorotatory. If left side, is called leviorotatory. Then complex generally coordination number 4 and 6, they show the optical isomers, but coordination number 6, and that is octahedral complex, and here if the identical ligand, that is a common for the optical isomers. If coordination number 4, if the structure is square planar complex, it never shows optical isomers because it has a plane of symmetry. Remember, optical isomers only shown by when there is no plane of symmetry, by a compound where there is a no plane of symmetry, and that is very important. Next we will see what are the examples of our optical isomerism. Optical isomers, these examples are existing. Here MAA, that means didentate ligand 1, X2Y2. Here X2Y2, that they are unidentate ligand where AA is didentate ligand. And now example, let us see CO, En and 2 ammonia molecule and 2 chlorido ion are surrounded by cobalt 3. Now En is 0, ammonia is 0, chlorido 2, that is why -2. So here +3 means the complex ion is positive, cationic complex. Now you see 1 En 2 NH3 2 Cl2. Here this is cis form. You can observe if I write NH3 NH this side and Cl Cl this side, and what is remaining? Ethylene diamine, or you can say ethane 1,2 diamine, and here you put this one. And now similarly, if you say what is the mirror image of this, that means you can exchange. Here NH3 comes to here, En comes to here, and Cl comes to this side. That means it is also cis, and that is mirror image, so it is optical active. That means here cis isomer of this compound is optical active, but trans isomer of this compound is not optical active, because if you say there is a plane of symmetry, but for optical isomers you require a non optical isomers required. It is a no plane of symmetry. Require no plane of symmetry, but in trans isomer there is a plane of symmetry. That is why trans isomers never shows the optical isomerism. Now next example type is MAA whole to H2. AA means didentate ligand 2 times, that means 4. Here coordination number 4 is plus 2, 6. Coordination number 6, that means it exhibits that octahedral structure. That means here example you take En, so cobalt in middle, En this side, that means that is cis form, and chloride, that is chlorido in this side, that it exists as cis form. Now it can show mirror image. Mirror image means here you can observe this En will go this side, this En will go this side, chlorido ion will come to this side. This exhibits as optical active, and this is mirror image. It forms mirror image. Again see, if 1 En ethylene diamine, you can put here 2 ammonia and 2 chlorido ion. Now here then if you say mirror image, just exchange, thus you feel that it is a mirror. How? It means En will come to here, NH3 come to this side, and NH3 come this side. Similarly chlorine will go this side. This is this is optical active, that is mirror image, but in transform it never shows because it has a plane of symmetry. Similarly, if the example you can say ethylene diamine, or you can say 1,2 ethane diamine 2 times, chlorido 2 times, that is why coordinates number 6, and chlorido minus 2, ethylene diamine 0, and so CO plus 3, that is here plus 1 charge. Now, if you see the cis isomer, then En one side, ethylene diamine one side, chlorido one side, then if you take the the mirror image, then ethylene diamine come this side and ethylene diamine come this side, chlorido group will come to this side, then left to right, right to left, that is optical active, and it has a mirror image. And so these are the two examples. Again we will see other examples of the octahedral complex which shows optical isomerism. Now you have seen cis isomer which shows optical active of the compound COEN whole 2 Cl2 square bracket close plus 1. That means here dichlorido bis-ethane 1,2-diamine cobalt 3 ion which shows cis isomer and trans isomer. Cis isomer I told it is optical active and shows mirror image, where the trans isomer see here this one opposite to each other, these two opposite to each other, that is transform. It never shows no mirror image here. It is optically inactive. Why? Because never forms mirror image. Now see, as it remains, if you change also remains same as it is, there is no changes, there is no mirror image, and this compound shows cis and trans isomer. Cis isomer which is optical active and trans isomer which is not optical active. Then come to type MAA3. AA means didentate ligand 3 times. That means here it is a didentate ligand into 3,6, coordinates number 6, octahedral complex. Let us see oxalato, which is a didentate ligand, and it is 3 times, so minus 6 plus 3 minus 3, that is an anionic complex, because charge is minus 3. Now what happened, you see this is the oxalato 3 times, so here 1, 2, 3, because there should be gap. If you start here, if you start from here, then this one leave it, then come to this and leave it place, then come to this. This is the oxalato 3 oxalato ions are there. Then here what is the name? Trioxalato chromate, AT, chromium chromate, and 3 minus 3. That means what to write? That is Roman numeral 3. Then here you can say 3 oxalato ion, as it is remains same, so it is not optically active. Sorry, it is optically active because you can change this position. OX here you can write, this one jump here, this one jump here, so it is optical active. And now this form it shows MAA whole 3. Similarly, anyone you can take, if you take chromium En3 instead of oxalato, you can put En. So I hope it is clear. This is a trans isomer which is not optical active. It is simply AA3 I have written. It is optical active. Optical active means you rotate the right side and left side equal angle but opposite, equal distribution or equal rotation but opposite sign. Opposite sign means one is positive, other one is negative. Next we will see other examples which show cis and trans both. Now you can observe this example where potassium plus 1 and this part is negative, that is anionic complex minus 1. So here neutral ligand, water is neutral ligand, and here minus 4 because minus 2 into 2 minus 4 it is plus 3. So it is anionic ligand. You can write here minus 1 and here also minus 1 like this. So what happened here? How can you write the cis isomer and trans isomer? First you write cis isomer, oxalato, water, and that is why it is cis form. Cis form can form mirror image. That means it is optically active. So here you can see this one jumps to here, this oxalato ion jumps here, this water jumps here. That means it can form mirror image. This is optically active. Which one? Cis isomer. So what is the name here? Dioxalato. It is not bis, it is a simple ligand. So dioxalato chromat 1. Now here, if you say trans isomer, opposite to each other, water is opposite to water, oxalato opposite to oxalato. This is transform but not optical active, because if you put again its mirror, same, there is no change of place. So transform is not optical active, only cis form optical active. Similarly, you take example, PT surrounded by 2 chloride ion and ethane diamine, 1 2 ethane diamine 2 times. So what is the name here? Dichlorido bis ethane 1 2 diamine platinum 2, because here plus 2 charge, sorry, platinum 4. This is the total charge of the ion and it is platinum 4. So you write dichlorido bis 1 2 ethane diamine platinum 4. And now you can see cis form. Cis form, you should write chlorido ion in this way or in this side also. If you write in this side, you put this one this side. So chlorido ion is here and ethylene diamine here, and corresponding to this is the cis position. So you should write here. Then is it mirror image or not? It form mirror image or not? Yes, because you change ligand Cl to here, En to here, this En to here, then it form mirror image. So you can see it is mirror image, mean it is optically active. That means here you can observe mirror image mean En transfer to here, chlorido transfer to here, En transfer to here. There is no problem. It is same meaning cis isomer. That is why it is optical active. But when you go to iso, that means trans isomer, what happened? Trans isomer, chlorido ion opposite to each other, ethylene diamine that is opposite to each other. If it is that is transformed and write the here mirrors, that means En, if you come to En is already there, and chlorine also same position, that means same result. There is no mirror image, so it is not optically active. And remember this side always this is mirror image mean this is D, dextrorotatory, this is levorotatory. Similar here, dextrorotatory, levorotatory. And now here I hope you can understand that point. If didentate ligand, then how can you at a two side the attachment is there regarding to cis form and transform? You think yourself correctly. That means oxalate you put mean you can't put oxalate here. You leave this place and put, because two side it is attached. The oxalate ion this side also, this side also. If I will write oxalato here, that in one place two ligand cannot attach. That is why oxalato here and water is unidentate, no problem. So this is the cis form. Optical active mean this jumps to here and this oxalato here and this water here, then it is cis optical active. And transform, that is now there is not any optical active nature, because the same position occupied that never forms mirror image. And similarly platinum plus 4 supplied surrounded by chlorido and ethylene diamine. Again you see En here, you can't write here because in one place two ligands cannot be attached. Similarly you write this is cis form, and also you can optical active, you say you can see here it is optical active, because if you see mirror image, then here En transport here, this En transport to here, chlorido here, that will form mirror image. But transform never forms mirror image, because there is no vacant place, so that it jumps here and it will comes to here, nothing, no new ligand is there. So transform never shows optical active, they never shows mirror image. I hope it is clear to you. and try to understand and try to see different examples, whether it is cis form or transform, whether cis form shows any optical active or not. After that, in coming video I will explain valency bond theory and other crystal field theory and others, and hope you will subscribe my channel VL Das Short and Sweet in Chemistry. Thanks for watching my video. Thanks again to all.